Calculating trig ratios with a trig table. This is 8.2c, and it's very important that you watched the previous videos for this lesson. We're on the third part of lesson 8.2. They're linked in the geometry playlist in the description. So in the last video, 8.2b, we found the length of a wheelchair ramp along the ground from a given segment and angle measure. And we can use a trig table to solve this same problem. Now sometimes we'll need to round an angle measure to find the sine, cosine, or tangent ratio. And we should know how to use a trigonometric table, so we'll be familiar with both the table and scientific calculator in the event we have one instead of the other. So here was the problem we used in the last video, but we used a calculator. Chris is building a wheelchair ramp for a doorway that is 1.2 feet above the ground. And to meet the Americans with Disabilities Act guidelines, the ramp will make an angle of 4.8 degrees with the ground. We know this AB is 1.2 now, don't we? So we're looking for the length of CB. And we're given AB as 1.2 feet, which is the leg opposite of angle C. And since the opposite and adjacent legs are involved, we'll use a tangent ratio. So if you remember, we were using sohcahtoa to help us figure out which one to do. So the T in toa would be followed by the O for opposite leg and then the A for adjacent leg. And that would be AB over CB. So the tangent of C would be the tangent of 4.8 degrees, and it would be this 1.2 over CB. And we can multiply both sides by the CB to get rid of this fraction here, and the CB over CB will cancel each other out, and we'll be left with 1.2 on this side. Then we divide both sides by the tangent of 4.8 degrees. These two cancel out as a 1, and we're left with CB is equal to, or BC, is equal to 1.2 divided by the tangent of 4.8 degrees. Now, looking on the trig table in the tangent column, if we look here very carefully, I don't see a 4.8 degrees. I see it goes from 4 degrees to 5 degrees. So what we do is 4.8 is closer to 5. We use the 5 degrees. Okay? So we're going to do 1.2, and when we look at the 5 degrees here, let's go in one more time. It is a 0.0875 in the tangent column because we're doing the tangent, okay, because it involved the opposite and adjacent legs. We do 1.2 divided by 0.0875, and it's approximately 13.72 feet. In the last video, when we used the calculator, it was 14.29. So we're not exact because we rounded to 5 degrees, but that's okay. We came pretty close, all right? If we have an angle measure that is a decimal, we round it to the nearest degree. So the 27.5 degrees would round to 28, 6.1 rounds to 6, and our 4.8 round to 5 degrees. And we decide if we need the sine, cosine, or tangent ratio by seeing which sides are involved to get the answer, and we use the mnemonic sohcahtoa to guide us. So remember, the sine is the opposite leg over the hypotenuse. That's our so. The cosine is the adjacent leg over the hypotenuse. That's our ca. And then the tangent is the opposite leg over the adjacent leg. That's our toa. And it's unlikely we'll find exactly what we're looking for every time we use a trig table, but we can get close. Now we can find the sine of A. Look at this triangle here. We have a 3, 4, 5 for our sides. And to find the sine of A, that would be the so in sohcahtoa, wouldn't it? So we'd have an O over an H, an opposite leg over a hypotenuse. So for the sine of A, the opposite leg is a 4, and the hypotenuse is a 5. And we do 4 divided by 5, and we get a 0.8. And we look on our trig table under the sine column for an angle measure that is the closest to 0.8. So looking into the sine column, we're looking for a 0.8. These are all too low. If we come over here, look at, there's a 0.7986 and a 0.8090. So it's a 53 degrees or a 54 degrees, but there's nothing that's exactly 0.8. So it's between these two. So what we do is we find the difference between our 0.8 and the two possible options. For the 0.7986, there's a difference of 0.0014. And for the 54-degree one, 0.8090, there's a difference of 0.0090. Well, that 1 is much smaller than that 9. So it's going to be much closer to this 53-degree as the measure of angle A. So that's the one we would use. And we can find the sine of B the same way. We would have a 3 over a 5. That's the opposite leg of B and the hypotenuse. 3 divided by 5 is a 0.6. And when we look on the trig table, it's going to be between 36 and 37 degrees because we don't have an exact 0.6. We find the difference between our 0.6 and these two, and we find that it's closer to 37 degrees. Okay? And the cosine of A is equivalent to the sine of B. If we look at our chart here, look at the cosine of A. It's going to be side B over C. Look, that's the same as sine B, sine of B. And the cosine of B is equivalent to the sine of A. This is A over C, and that's A over C. See? All right? So you can find the cosine by finding the sine. See what I mean? Okay? So I hope this was helpful and gave you a little intro into using a trig table. And I know we're in geometry, but you're going to have to use these a little bit. Our next lesson for 8.2 is trigonometric ratios and complementary angles, and then we'll finish it up with inverse functions before moving on to 8.3. So this lesson 8.2 had a lot of videos to it, but each one should be helpful to you, and I hope that this was helpful. I'll see you next time. Bye.